Hello and welcome aboard. Captain Joe here. Ever wondered how pilots land a jet in thick fog, unable to see the runway? The answer? Autoland. Imagine a massive jet traveling at over 150 miles per hour, touching down perfectly on a runway the pilots can't even see. This isn't science fiction. It's a routine, high-tech procedure that's made flying safer than ever. Autoland is a seamless partnership between advanced aircraft systems, ground technology, and highly trained pilots. Today, we'll reveal how Autoland works, what's required from both planes and airports, and why pilots remain essential, even when the computer's in charge. We'll break down the Instrument Landing System, or ILS, the invisible pathway guiding jets home. Buckle up as we explore how modern jets can fly blind and still land with incredible safety and precision. Let's get started. So, what is Autoland? It's a system that fully automates the final approach, landing, and rollout. No manual flying needed in the last moments. Think of it as autopilot's most advanced mode, using radio signals from the ground and onboard computers to guide the plane to a perfect touchdown. Pilots program the flight computer, tune in the ILS, and engage Autoland with multiple safety checks. The system makes constant tiny adjustments, flying the plane down an invisible electronic funnel to the runway. As the plane nears the ground, radio altimeters trigger the flare, raising the nose for a smooth landing. Autoland keeps the jet aligned and slows it down, while pilots monitor and take over once it's safe to exit the runway. It's a seamless, automated sequence, precision from sky to pavement. The backbone of Autoland is the Instrument Landing System, or ILS. This system is the unsung hero of modern aviation, quietly guiding thousands of flights safely to the ground every day, especially when weather conditions make visual landings impossible. Without ILS, many airports would be forced to close during fog, heavy rain, or snow, causing massive delays and disruptions. ILS uses two radio beams, one called the localizer, which provides left-right guidance, and another called the glide slope, which gives up-down information. Together, these beams create an invisible but incredibly precise path that leads the aircraft directly to the runway threshold. Pilots and autopilot systems alike rely on these signals to stay perfectly aligned, even when the runway is hidden from view. Not all ILS systems are equal. They're divided into categories, each with its own level of precision and capability. These categories determine how low an aircraft can descend before the pilots must see the runway or decide to go around. Cat 1 is the most basic category, guiding pilots down to 200 feet above the runway. If the pilots can't see the runway environment at that height, they must abort the landing and try again or divert. This is the minimum standard at most airports, and it works well in good weather. Cat 2 steps up the precision, allowing approaches down to just 100 feet above the ground. This category sometimes supports Autoland, but pilots still need to see at least some of the runway lights to continue. It's a crucial tool for landing safely in mist, light fog, or at night. The real magic happens with Cat 3, which is designed specifically for Autoland in the worst weather conditions imaginable. This is where technology truly takes over, allowing landings that would be impossible by hand. Cat 3A allows landings with as little as 200 meters of visibility. At this point, pilots may not see the runway until the very last moments, relying almost entirely on their instruments and the aircraft's automated systems. Cat 3B pushes the limits even further, going down to just 50 meters of visibility. In these conditions, pilots might not see the runway at all until the wheels are already on the ground. The aircraft's Autoland system does nearly everything from approach to touchdown. Cat 3C, in theory, allows for landings in zero visibility, meaning the pilots could land without ever seeing outside. However, this isn't used in practice, because taxiing an aircraft when you can't see anything at all is simply too dangerous, even with ground radar and guidance. Only a select few airports equipped with the highest ILS category and strict procedures can support true Autoland operations. These airports invest heavily in technology, maintenance, and training to ensure every landing is as safe as possible, no matter the weather. This technology is what lets jets land safely when the world outside is just a wall of fog. Thanks to ILS and Autoland, air travel remains reliable and safe, even when nature throws its worst at the runway. For Autoland to work, both the aircraft and airport need specialized, certified equipment. This technology ensures that planes can land safely even in poor visibility conditions, such as heavy fog or rain. the plane must have a fail-operational autopilot. If one channel fails, another takes over instantly. This redundancy is crucial for maintaining control during critical phases of flight. Modern airliners use 2 or 3 independent autopilots, plus dual radio altimeters and multiple navigation receivers. These systems work together to provide accurate data and ensure the aircraft follows the correct approach path. Every critical system, flight controls, hydraulics, electrics, must have backups and pass rigorous certification. This ensures that even if one system fails, another can take over without compromising safety. On the ground, the runway needs a full Cat-3 ILS with backup power and advanced monitoring. This system provides precise guidance to the aircraft, ensuring it stays on the correct glide path during landing. Airports install special lighting, centerline, touchdown zone, and stop bars to help pilots see during rollout. These lights are essential for maintaining situational awareness, especially in low visibility conditions. During Cat-3 operations, strict procedures keep vehicles and other planes far from the ILS antennas to prevent signal interference. This ensures the integrity of the guidance signals that the aircraft relies on. Air traffic control holds everything back, ensuring the ILS signal stays pure. Controllers coordinate closely with pilots to manage traffic and maintain safe distances. Only when every piece is in place can Autoland operate safely. The collaboration between the aircraft's systems and ground-based equipment is vital for a successful landing. It's a high-stakes partnership between air and ground. Both sides must work seamlessly together to ensure the safety and efficiency of every landing. With all this automation, you might think pilots just sit back during Autoland, but their role is more critical than ever. Before approach, pilots run detailed check systems, airport certification, weather, and their own qualifications. Only specially trained simulator-tested pilots can perform Autoland. In the cockpit, one pilot monitors the autopilot, the other cross-checks instruments and communicates with ATC. They're a team, constantly verifying the system is working as expected. Most importantly, they're ready to take over instantly if anything goes wrong. Autopilot disconnects, system errors, or unstable approaches. Pilots are the ultimate backup, ready to fly manually at a moment's notice. Their expertise and vigilance are the final safety net. Automation is brilliant, but human judgment is irreplaceable. In Autoland, pilots are system managers, troubleshooters, and the last line of defense. Autoland is powerful, but it's not a cure-all for bad weather. The biggest limitation is infrastructure. If the airport doesn't have a high-category ILS, Autoland isn't possible. Weather can also stop Autoland's strong crosswinds or wind shear exceed system limits, forcing manual landings or diversions. Runway conditions matter too. Autoland isn't approved on runways with heavy snow, slush, or ice. The aircraft itself must be in perfect shape. Any technical fault can disable Autoland. The system constantly self-checks, and if anything's not right, it won't engage. Safety demands perfection. If conditions aren't ideal, pilots take over. Autoland is a specialized tool, not a universal solution. Autoland has revolutionized aviation safety, especially by dramatically reducing the number of accidents where planes inadvertently hit the ground in poor visibility. Before Autoland, pilots had to rely solely on their training and senses to land in fog, rain, or snow, conditions that could easily lead to disorientation or mistakes. Now, with advanced technology guiding the aircraft, the margin for error is much smaller, and passengers can feel more secure even when the runway is hidden from view. The system's precision ensures landings in the touchdown zone every time. No fatigue, no distractions, no visual illusions. Autoland doesn't get tired or second-guess itself, and it isn't affected by stress or workload. This consistency is crucial, especially during challenging approaches where even a small error could have serious consequences. Automated flare and touchdown means smoother, safer landings and less stress on the aircraft. The system calculates the perfect moment to begin the flare, reducing the risk of hard landings and minimizing wear on the landing gear and tires. This not only protects the plane, but also makes the experience more comfortable for everyone on board. But Autoland isn't perfect. Over-reliance on automation is a risk. Pilots must remain vigilant, ready to take control if something goes wrong. Technology can fail, and unexpected situations can arise, so human judgment is always needed as a backup. That's why pilots train rigorously to monitor and intervene if needed. In simulators, they practice handling system failures, sudden weather changes, and other emergencies, ensuring they're always prepared to step in and keep everyone safe. The ILS signal must remain pure. If a vehicle or plane strays into the critical area, it can disrupt guidance. Even a small interference can cause the system to give incorrect information, so strict procedures are in place to protect these zones during Autoland operations. Pilots are trained to spot unstable approaches and go around if needed. If the aircraft isn't perfectly lined up or the landing doesn't look right, they'll abort and try again, always putting safety first. Safety is a shared responsibility. Pilots, air traffic control, and ground crews all play vital roles. Communication and teamwork are essential, ensuring that every landing is as safe as possible no matter the conditions. Autoland is a marvel, but it's only as safe as the people and systems supporting it. Human oversight remains essential, and the collaboration between technology and skilled professionals is what truly keeps aviation safe for everyone. Here's a twist. While jets can land themselves, takeoffs are always flown by pilots, even in low visibility. Why? Takeoff is dynamic and risky. If an engine fails, pilots must instantly decide whether to abort or continue. No computer can yet match a human's split-second judgment in these scenarios. Pilots also steer the plane down the runway, often in crosswinds, using visual cues. There's no certified system for automated takeoff guidance. That's why takeoff visibility requirements are often stricter than landing minimums. Once airborne, autopilot can help, but the initial liftoff is always manual. The combination of high thrust, low altitude, and changing conditions demands human skill. For now, getting airborne is a job only pilots can do. In conclusion, Autoland is one of aviation's greatest achievements, a blend of technology, infrastructure, and human expertise. It's not magic, but a symphony of redundant systems, precise radio beams, and rigorous procedures. Aircraft and airports must invest heavily in equipment and training to make it possible. Pilots haven't been replaced. Their role has evolved into expert system managers and vigilant overseers. Their training and judgment are the ultimate safety net. Autoland has made flying safer and more reliable, but it's a specialized tool with clear limits. It's a testament to human ingenuity, navigating the unseen, but always with pilots at the helm. Next time you land in fog, remember, it's not magic, but mastery of both machine and mind. Thanks for flying with us. See you on the next journey.